Good morning. So I hope you've watched yesterday's video where I talked about how polymorphism is important for object-oriented programming and what is the essence of polymorphism and how is it really useful to us. Now, it's very important to go through that video so that you have a conceptual understanding of what polymorphism is. Fine, then let's move ahead with our normal slides. Now, as far as I remember, we had done the operator delete operator, right? That was the last slide we had done. Now, continuing with polymorphism, let's go back and look at this code. What we are trying to do here is we are trying to create an object dynamically now using the new and delete operator. So class A remains the same, right? You have one function called as display, which is a public function. Class B is inheriting all the properties of class A. Class B has got its own public function, which is again display. So you have display in both class A and class B. Let's go back to the main. You find that we create an object here. There are two objects which are being created dynamically. However, the important thing to note here is we are creating a pointer of the base class, right? So if you refer to my old video, the video which I actually published yesterday, this P is nothing but a remote control, a universal remote control of the base class. So I can create a pointer variable of the base class and I can point to the objects of the derived class as well as its own object. So if you see here, P is a pointer of the base class. This P is pointing to the new object which is created by using the constructor of A, and then you have P pointing to the display, which is it's going to invoke the display of the class A. Next, we again delete P and then we point to another object, which is the derived class object, and we invoke the display method once again. Now, what exactly happens here? You'll notice that according to the properties that we had discussed, it's always the display of the base class which is going to be called. So you get A is equal to 10 and again A is equal to 10 printed. Now here B is equal to 10 is incorrect. It should be A is equal to 10, right? The value of A is 10 and this B is equal to 10 is actually incorrect. This has to be A. So I'll just show it that this is incorrect, and in place of this it should be A is equal to 10. Right, now why does this happen? Because when you declare a pointer of the base class, the compiler binds that pointer with the functions of the base class. That means no matter where the pointer is pointing to, whichever object the pointer is pointing to, when it invokes the display method, the display which is specified or which is defined in the base class is actually bound to that pointer. So it's always the base class function which is going to be invoked. Why this happens is because this binding is done at compile time. So this is an example of static binding. Now what should we do in order to achieve polymorphism? So in order to achieve polymorphism, what we should do is we should be able to invoke the function of the class to which the object to which this pointer P is pointing to. So in this case, if you could get an output A is equal to 10 and B is equal to 20, then we achieve polymorphism, right? How do we do it? There's a concept called as virtual function. Now what exactly do we do in virtual function? We tell the compiler, don't do a static binding at compile time. Don't do the binding at all. We will do the binding at runtime. So this function display of the base class is not bound to the pointer P. When is the binding done? It is done at runtime. So whenever a pointer is pointing to any object, whether it's object A here, object of the base class or the derived class, the pointer will be bound at that instance. That means the binding of the function will take at the runtime. And if you can achieve this we will achieve polymorphism. So before we actually look into how we can do this using virtual functions, let's look at this important property. Now the base class pointer can point to the base class object as well as to the derived class object. You've already seen that. We created a pointer P, we pointed it to the object of the base class, and we pointed it to the derived class object. However, if you create a pointer of the derived class, you can only point to the object of the derived class. You cannot point to the base class object. Fine then. Now let's look at how we can write a virtual function to achieve polymorphism. So before we actually get into virtual function, it is very simple in the code. We just need to use a keyword virtual before declaring a function in the base class, right? But let's try and see what exactly a virtual function is. Now, what are virtual functions? It's a mechanism which helps in invoking the member functions of the object that is being pointed at by a pointer instead of the pointer type. So what exactly is meant here is that rather than looking at the pointer type and associating an function with the pointer type, we would look at to which object the pointer is pointing to and invoke the method of those objects and not to an object to which the pointer is defined, right? So which means that if you create a pointer of the base class, the pointer should not be bound to the base class function, but it should be bound to those functions whose objects it is referring to, right? So that is the whole point about a virtual function. So there are certain properties and of virtual functions that you must remember. We'll discuss those properties, but a virtual function is also a member of a class. It is declared with a virtual keyword. So it's the same thing like you have display. We just have display in the base class, but what you need to do is you need to just use the keyword virtual before while defining the function. That's all. Now usually it has a different functionality in the derived class. That's true, because you would want, when you are trying to achieve polymorphism, like you looked at an animal example in the previous video, we have the sound function on the base class and we have a sound function in the derived class. Now the purpose of having the sound in both is that you don't want the sound of the base class to get invoked, because the sound functionality that you have mentioned in your derived class is going to be different from what is there in the base class, and that is the whole point. So only when you have two functions of the same name in the base class and the derived class, and both the functions should have different implementation, that means they should have different functionality, that is where your virtual function comes into the picture, right? And when you make a function as virtual, that means the function call is not done at compile time, but it is done at runtime, right? Now non-virtual functions are basically done at compile time, and that mechanism is called a static binding. I've discussed that in the previous slides. And virtual member functions are done at runtime, and this is an example of dynamic binding. Some properties and rules of virtual function: it must be a class member. You cannot have a friend function which is virtual. It should not be static. It should not be declared with the static keyword. Now the point is, if you are trying to declare something with the keyword static, you are trying to do a compile time binding there. So we have a contradiction here. We can't do compile time and runtime at the same time. So it should not be static. Constructors cannot be declared virtual. Now this is an important point, and I'm going to give you an assignment on this as to why. So you need to think and let me know your thoughts on why constructors cannot be declared as virtual. Although constructors are class members, they should not be declared virtual. Now the virtual functions must be defined in the public section of the class. Important point. And virtual function mechanism only works if there are two functions with the same name and the same argument. That means you need to have the same prototype of the functions in the base class and the derived class. If the prototype changes, then we don't have this virtual function, is of no use. That means what we are trying to achieve here is not function overloading, but what we are trying to do is we are trying to override a function. So this is an example of function overriding. All right. So let's move ahead and let's see how just by using the keyword virtual we can achieve polymorphism. So this example is an example of polymorphism. Now you just note there is only one point where a change has been done. So I have declared the display function in my base class with the keyword virtual. Now once I do this, what happens? The binding of display is not done at compile time, but it is done at runtime. So I create a pointer of the base class. This pointer is pointing to the base class object. Now when I invoke display, I will have display of this invoked. Now this pointer changes and it points to the object of the derived class. And now in this case, when I use display, it is this display which is invoked. Now this is what polymorphism is all about. So in this example, we have invoked polymorphism and we have changed the properties of the derived class pointer by using the virtual keyword. Right? So look at the output here. The output is A is equal to 10 and B is equal to 20, and that's exactly what we intended to do. Now virtual keyword, what it does is it does the runtime binding, not the compile time binding. Now how exactly a virtual function works, we will be studying in the next class. However, some of the key points that are there from today's video and the class is: binding is a link between a function call and the real function that is executed when the function is called. This I have explained it in the previous slide. You can go through it. Early binding is when the compiler knows which function to call before executing, so which is also called as compile time binding. Dynamic binding is linking the function call to the actual function during the program execution or runtime. And the virtual keyword prevents the compiler to perform early binding. So these are some of the key points that please go through them. And if you have any doubts, you can always ask me during the class. Right? So how exactly is this virtual function working behind the scene? What exactly happens? How does the property of the base class pointer change when we use a virtual pointer, and how does it happen internally? So these are the few questions that we are going to discuss in the next class. Now this is also important, so I hope that all of you attend the next class and also watch the next video, which I would be releasing soon. So for now, we have done polymorphism, and please practice the code and write the program and see it for yourself how polymorphism can be achieved. It is very simple, just by using the keyword virtual. However, we need to understand the background and the way things are happening behind the code to implement this polymorphism. So I hope you understood today's talk, and please go through the video because I'm finding that very few people are referring to the video. There are only few views, so I would want all of you to go through the video first before you come to the class. So happy learning. See you tomorrow.